Hello, my name is Rob Reynolds. Welcome to College Algebra. Today we're going to look at the Conics section and looking at section 11.1. Looking at this, we're going to study circles. This could be an ellipse. If you slice the cone, this is why they call it the conic section, because it's all this, the study of the slice of the cones. Today we're going to look at the parabola, and then on another section we're going to look at a hyperbola, which is kind of two parabolas put together. The important thing you need to know about the parabola is that the distance from the vertex to the focus, and I usually put an X for the focus. Focus is not a point on the function. It simply helps generate the parabola. The definition of the focus is all the set of points that are equal distance away. So this distance to the directrix. So the distance from the focus to any point on the parabola is equivalent to, and that includes this point, or this distance. So from the focus to the vertex, we're going to call this A. That's equivalent, so we'll double hash this. That's equivalent to this, so we'll call that A as well. So that distance, which happens to be from the vertex, so if it's any point, you bet, it's congruent. But a special point is the vertex, and we're going to study how that distance away from the vertex to the focus is the same distance from the vertex to the directrix. So maybe you've learned two things today. A focus and a directrix helps shape the parabola. So they're proving this. If you don't understand all this, this is nice. Oh, good. A lot of people, this is the theory behind it. But basically they're saying, again, the distance from the focus, which I usually put as an X, to any point on the parabola is equal distance from that point to the directrix. But again, what we're really going to be interested in is this distance. We're going to call that A. And you can see they use an A in our parabola equations. So you may be thinking, well, what formulas do I use? And so they give you a formula, and then this is going to be our very first example. But I would recommend using this cheat sheet that I've built. So be careful. We've got a vertical parabola and we have a horizontal parabola. Normally you're used to y equals x squared, so you know that that's a vertical parabola. But notice that the vertical parabola, we've got the same thing. We just have x minus h being squared, where this is h and k, which is the center of the parabola. But something new is introducing is this 4a. 4a did not appear over here. And notice that this 4a is always on the side that's not being squared. So I'm not going to use this. In fact, some of you are familiar with y is equal to a x minus h quantity squared plus k. So we used this formula earlier in college algebra. So we're going to stay away from that formula, even though it does have an a in it. This a is not the same thing as this 4a. So we're going to explore a little bit different formula for this. But notice that the 4a is on the side that's not being squared. Same thing over here. 4a is on the side that's not being squared. We're over in our old definition. A was on the side that was being squared. So don't get the old formula mixed up with the new formula. When I start talking about focus and directrix, I'm going to start using the 4a definition. So this very first example, it says find the equation of a parabola with a vertex of 0, 0 and a focus. I'm kind of a visual person, so I'm going to just sketch this real quick. So I want the vertex at 0, 0. We'll put a point there, and I'll label it V. And the focus is at 3, 0. So 1, 2, 3. I'm going to put a F here. So all of a sudden you can see, is this going to be a horizontal or vertical? Well, since the parabola always goes around the focus, then I know that it's a horizontal. So I'm not using the vertical in this case. I'm going to use this horizontal. So I'm going to write down the equation. Y minus k quantity squared is equal to 4a x minus h. Notice that 4a is on the side that's not being squared. And they tell me that h and k is 0, 0. So that's always the vertex, h and k. The focus is 3, 0. So I can tell that this distance here, a, must be 3. Because if this is 0, 0 and this is 3, 0, So now I know that this is 4 times 3, or a whopping 12, and I've got x minus 0, which is the same thing as just 12x on this side. And over here I've got a y minus 0 quantity squared, which I would call y squared. So there's the equation for our very first example, which matches what the author has here, y squared equals 12x. There's some other things that we haven't discussed. It's called the lattice rectum. The lattice rectum, I'll abbreviate as LA, is always defined as 4a. Well, look at this. The 4a was 12. So in this case, that's telling you how long this lattice rectum is. So the lattice rectum will help identify 2 more points on the parabola. So we know that the focus was at 3, 0. I'll put an x there because I don't know why, I just usually do. But notice that if we let x equal 3, because we know that that's where you can always identify these other 2 points, the points that are on the parabola, by letting x be, well, in this case, the focus is x is 3. So if you let x be 3, then we get y squared equals 12 times 3. Y squared is 36. And if you take the square root of that, that's why we're getting y is equal to plus or minus 6. So that's generating these other 2 points. But notice that that total distance of the lattice rectum is 4a, or in this case, the 4a is a 12. And that certainly is 12 units, because from here to here was 6 units, and from here to here was 6 units. The total is 12 units. So the lattice rectum is probably a new term as well. So here it goes. It says analyze the graph. And whenever it says analyze the graph, we're going to look at several things, trying to find the vertex, the focus, directrix, and the lattice rectum, which we just talked about. So if I were to put this into 4 times 2, x minus 0, I can see clearly, I think, that the value of a is 2, and the vertex is at 0, 0, because that's my h and my k. So I'm going to plot the point 0, 0. That's where the vertex is at. I know that this is a horizontal parabola because it's in the form y squared is equal to 4a x, which matches this definition down here. So basically, the 4a is on the side that's not being squared, which is this x term. So I can see that, that's matching my horizontal. So I'm going to move horizontally 2 units, the distance of a, to find my, and if it was negative 2, then it would go the opposite direction. So maybe in my notes, this would be a negative a, so this would be a negative 4a up here, because that's actually going off to the left. So maybe you can make some corrections on the notes that I have. So if a is positive, it's going right. If a is negative, it's going left. Similarly over here, if I was talking vertical, if a was positive, it goes up. A is negative, it goes down. But since a is positive, or better yet, 4a is positive, I'm going off to the right. The other thing I want to do, I don't know if the parabola looks like this, or perhaps the parabola looks more like this. So this is where the lattice rectum comes in handy. So let's see, I've got the focus at 2, 0. Oh, that means the directrix is out here, 2 to the left. So that's going to be x equals negative 2, because remember, a is that same distance away. So if this distance is 2, this distance is 2. And the last thing, that lattice rectum is going to help me just determine how wide or how narrow the parabola is. So I'm going to let x be 2, because I know this is the focus, which is 2, 0. So I know somewhere along here the parabola points, maybe they're up here and down here, I don't know. So let's plug this 2 into the formula and get what? Y squared equals 8 times 2, so y squared is 16, so y is plus or minus 4. So now I've got 2, 4 is a point, and 2, negative 4. Those are going to be the endpoints of my parabola. I'm going to plot those. That would be here at 2, 1, 2, 3, 4, and 2, negative 4, 1, 2, 3, 4. So now I know I can go for the star. Well, I was really close the very first time I graphed this thing. So I'll get rid of everything else, and it looks pretty close to the blue. So the final parabola looks like this happy face going through those star points. All right, where the total distance of the lattice rectum is 8, because 4a is 8. So I know this is 4 up and 4 down, and that's why I can label this point 2, 4 here, and name this point 2, negative 4. One last thing. There's a lot of information in here, more analyzing of graphs. You can look at the PDF file, but I did want to share one last thing before I took off. Sometimes the equations are not in the correct form. For example, they're going to be in standard form, but not standard graphing form. So we'll have to complete the square. So in order to complete the square, I kind of want to get all the x's on one side and all the y's on the other side. And the reason why I'm doing that is because I'm trying to match it onto the formula sheet to try to figure out if this is vertical or horizontal. I've left a space over here so that I can complete the square. So I always do the star step. Half the middle term, 4 divided by 2 squared, is, let's see, 4 divided by 2 is 2. 2 squared is 4. I call that 4 a magic number. So I'm going to add 4 to both sides, because then this can be rewritten as x plus 2 quantity squared equals, I'll factor out a 4, y plus 1. Now be careful. Make sure when you're doing this that the 4a, this is so important, that 4a has to be on the side that's not being squared. And in this case it is. If I would have ended up with a 4 over on this side, I would have divided it off and said 1/4, and then 4a would equal the 1/4. So just make sure that your final equation is matching something that's on the worksheet. So it looks like this is matching my cheat sheet, where I've got the vertex. Looks like I'm going to be using this formula, so I know it's vertical. So it looks like the vertex is going to be at -2, -1. The focus can be found by setting 4a equal to 4, so a equals 1. And so I'm going to start sketching a graph here. I've got the vertex, -2, -1. I've got the value of a. I know it's vertical, and so the focus is 1 unit up, and that's going to put that at what? -2, 0. The directrix is 1 unit the other way, so the directrix is going to be y equals -2. And the last thing I want to know is, I shouldn't have drawn that in because I really don't know what the lattice rectum is. I know that its distance is 4a, its total distance is 4a, or in this case it's a 4. I know 4a is 4, but that means that I'm just going to move along left to right, moving along left to right. Well, I know that this total distance here has got to be 4, so this distance here has got to be 2. So I know there's a point here, and if I go 2 more over here, I know there's a point here. Again, I did that from the lattice rectum being 4. In fact, you could even divide by 4, and remember a is 1, so if you divide both sides by 4, you can see. But remember, a is not what I'm interested in. A is this distance from here to here and to here to here. I'm talking about the lattice rectum now. I know this total distance is 4, so that means this is 2 and this is 2, so I'm just going to move 2 units to the right. This point better be 0, 0, and this point is -4, 0, and I believe that's what the author, oh good, that's what the author has as well. And boom, there's his equation. All right, if you have any questions, feel free to email me.